Welcome to Wheel of Science. Please welcome your host, Edward. Edward? Sorry folks, we're gonna have to cut to Kevin's
Woohoo! This is so fun! I love skateboarding! Woohoo! This is a blast! Yeah! Whoa! Yeah, let's do some more!
Edward, it's time for the show.
Huh? Hold on.
Wheel of Science.
What?
It's time for the show.
No, it's not. That's in 30... Oh my gosh! Let's go!
Wow. Whew, that was fun. But now it's time for Wheel of Science. Wheel of Science. Wheel of Science, bro. Wheel of Science. Wheel of Science. Woo! Let's look at the board for this week's theme. Okay, well, thanks, Edward. Well, the whiteboard says that this week's theme is Learning Target 1 and 2. Learning Target 1. I can determine the number of atoms for the reactants and products in a given molecule. Learning Target 2. I can apply the law of conservation of mass and balance complex chemical equations. Back to you, Edward.
Thanks. Now, it's time to meet the contestants. If we walk over here, they're in their cages, ready to go. Over here, first up, we have, he's mean. He's green. He's a fighting machine. He's James the Turtle. Woo!
Edward.
Yeah?
That's enough.
Okay. Moving on. Next up, we have he's good. He's great. He's the gerbil from Minnesota. He's Dasher. He looks ready to fight. Let's go. Woo! All right. First up on the list is James. All right, James, spin it. Oh, yeah, sorry. Let me just give it a kick for you. All right, he got a 1. Let's walk over here and see what that question is. We're coming over. Let's see what this question is.
Okay, James, your question has 2 parts to it. The first part is, what does a subscript do in general? The second part of the question is, what is the subscript and what does it do to sodium in this example, Na5?
Just let me slowly, leisurely walk up here. All right, James, what is your answer? Oh shoot, let me think. Is the first part of this question, it tells you how many atoms of an element there are in an equation? He's right. You got 1/2, but what's the other half? All right. Well, you said Na5, right? Yes. All right. So the 5 is the subscript. And the subscript, which is 5, tells you that there are 5 atoms of sodium present. He's right. He won that round. Woo! All right. Good job, James. Now let's go to round 2 for Dasher. All right. He looks ready to play. All right, Dasher. Spin the wheel. Oh yeah. Sorry about that. Didn't know you were in that little ball. Let me just spin it for you. Hi-ya! Yeah! All right. It's a 2. Let's go over there and see what question 2 is.
All right, thanks, Edward. Question 2 is, what does a coefficient do in general? The second part of this question is, what is the coefficient in this example and what does it do? 3kNa.
Let's walk over here and see what he has to say. Dasher, what is the answer to that question? Do I have to answer? Of course you do. That's kind of why you paid the $200 billion fee to be on this show. If I have to, I don't want to answer that. But if I were to answer it, this is what I'd say. I'd say coefficients multiply every substance by how large it is. In this example, the coefficient is 3, and it multiplies potassium and sodium by 3. So then, there are 3 atoms of both potassium and sodium. There, are you happy? I'm pretty happy, but are you happy? Well, you should be, because you just got it right! Good job, Dasher. Way to get it right. James, time for your next question. Don't worry, I know you can't hit it because you're in the cage, so I'll do it for you. And it's a 7! Question number 7. It's over there. Let's go see what it is.
Question number 7. This is for you, James. Okay, what are the reactants and what is the product in this chemical equation? Na2 plus K12 yields 2Na2 plus K12.
Let's walk over and see the answer. James, do you have your answer?
Yeah.
Okay, good. Let's hear it. Well, you said Na2 plus K12 yields 2Na2 K12, right? That is correct. So, the reactants are Na2 plus K12 on the left side. That's right. So, that must mean that the product is on the right side, which is 2Na2 K11. What? Oh, my bad. K12. That's right again. Great job. Good job, James. All right. Dasher, it's your second time. Are you ready to spin? I'm just messing with you. I'll kick it. It's a 5. Let's go see what question number 5 is. Oh, what? Oh, I'm sorry. I just heard that question number 5 is a drawing question. So let's go get you a piece of paper and a pencil. All right. There you go. Got your pen and paper. Time for the viewers to go see what the question is.
All right. Dasher, question number 5 is, how can you balance this chemical equation? The chemical equation is 2Au3 plus Kr2 yields AuKr.
All right. Since it's a drawing question, he might need some time. So we'll cut back in about 5 minutes maybe, or until he's finished up. And then we'll see if we got it right or wrong. See you later. 3, 2, 1. Beep! Timer's up. Let's see if you got it right. All right. So, let's show the viewers what he has put down. He wrote down how many A's there are, which is 6. Next, he wrote down how many KRs there are, which is 2. Next, he went over to the product side, and he saw how many AUs there were. My bad. These are AUs. It's hard to read upside down. And then he wrote down how many KRs he had. Ooh, looks like he's made a mistake. He changed the subscript. There's a 2 there, but you can't put a 2 there because there's not one here. So far, I think you might get it wrong because everybody should know that whenever you balance a chemical equation, you cannot change the subscript. Only coefficient. Remember that, little kids watching. So, from what the looks of it, I think you might have got it wrong. Let's see, double check. I think he got it wrong. Yeah, I'm sorry, Dasher, but you got it wrong. You pretty much just copied what you put in the reactant side in the product sides. They're exactly the same. I'm sorry, but you didn't earn a point. I'm so sorry, Dasher, but let's move on. We're coming over to James to start his round 3. All right, James, let's kick it. Ooh, it's a 10. All right, let's come over here and see what question 10 is. And let's have them read it.
Okay, James, question 10 is how do you balance this chemical equation? H3 plus 2O5 yields 2H plus O2.
All right. Since it's another drawing one, I was just going to give him another piece of paper. All right. Let's cut back whenever he's all done and see what he put down. All right. Let's see what he put. So, first, what he did was he laid it all out like so. And then he also did what Dasher did, which is very good. Write how many hydrogens you have and oxygens you have, which are 3 and 10. Very good. And then he did the same thing over here, and he put 2, which is very good because that's what the coefficient says. And then he put 10. My bad. He put 2 because that's what the subscript says. And then what he did was he made them balanced by changing the coefficient, which is the only thing that you can change. So he changed this coefficient from a 2 to a 3, which makes this hydrogen 3. The hydrogens are all paired up, so that's good. But the oxygens are still 10 and 2. So what he did was he put 5 as the coefficient because 5 times 2 equals 10. Put a 10 right there, which he did. And then he has the oxygen, 10, 10, hydrogen, 3, 3. That's all balanced. So then he wrote out his final product, which is H3 plus 2O5 yields 3H plus 5O2. That's correct! He got it right. Very good, James. Good job, James. All right, let's go over here to Dasher and see what he gets. All right, it looks like he got a 4. Woo! All right, let's come over here to see what question 4 is.
Question number 4. This is for you, Dasher. If you have 200.4 grams of water, how many grams of hydrogen reacted with 125.6 grams of oxygen?
Very good question. But since this one is a writing question, we're going to have to cut it out and give him some time to write. All right, let's check his answer. It seems like he has finished, so don't mind if we look. All right. I don't think this is right. If you got 204 grams of water, then how do you put 326 grams of hydrogen mixed with the oxygen? I don't think that makes sense. This is wrong. But I'm pretty sure I know what you did. You added them. You should have subtracted them. And that should have got you 74.8 grams of hydrogen. Sorry, Dasher, but you lost that point. Oh, so sorry again, Dasher. But, moving on again. Whew. And let's spin for James. All right, James, are you feeling lucky about this one? You might win, but you never know. You might also lose or tie. So much suspense. Let's find out. Ooh, it's a 3. Let's see what question number 3 is.
All right, James. Question number 3 is, if 20.2 grams of hydrogen equals 728 grams of water, how many oxygen grams were used?
He's finished, so let's see his answer. All right, just to clarify, the question was 20.2 grams of hydrogen equals 728 grams of water. And we asked him how many oxygen there was. This is what he got. It looks like he's got it right. He did it right. He did 728.0 minus 20.2 equals 707.8 grams of oxygen. But since he didn't label it, we're going to have to either mark that half or mark that all. We'll come back to you after the judges have decided. We have just received a letter from the judges, and they have decided that it will be marked as half off. That means he still got half points for getting the correct answer, but he got half off for not remembering to label. Remember, you must label. Hello, everybody. Welcome back. We have just set up this giant podium behind this gigantor curtain. Behind this, we have revealed the winner. But don't worry, I have not seen who has won. This will be both exciting for me and you. All right, Craig, bring it up. Woo! As you can see, James has won. He has won an entire box of animal crackers. Our sponsors, go get them. They're very good. All right. And in second place, last but not least, we have Dasher. He's a little shy. He's not used to losing. So let's just let him be. And look at the winner, James. Wow. Great job, James. You really know your science. How does it feel to win? It feels amazing. I can't wait to go home and show my ma. Well, there you have it, folks. Thank you for watching Wheel of Science.